In this video, we will discuss about Brewster's law. For that, let me consider a transparent medium, something like a glass. Okay, let this be a glass and this be air. Compared to glass, this air is rarer and this glass is denser. And let me consider an unpolarized light like this. And an unpolarized light basically means a light which has vibrations in more than one direction. Let it have a vibration in this direction, that is in a direction parallel to this plane, and one into the plane If I take this blackboard as a plane, and this vibration will be parallel to that plane, and this vibration is directed into the board or into the plane. So this is the unpolarized light. Okay, like this, and let it hit the surface of the medium at point, let's say some A. This point be some A, and let me draw a normal. Normal is always perpendicular to the surface, that is, this angle will be 90. Now we have two rays. One ray will get transmitted into the transparent medium like this, and the other will be reflected like this. Okay, and by definition we have the polarizing angle, that is IP. See, this is the polarizing angle, and we know at the polarizing angle, or we call that as Brewster angle, this reflected ray, see, this is the reflected ray. The reflected ray is polarized. Okay, that means it has vibrations only in one direction. See, this vibration got cancelled. It has only vibrations in a direction into the plane of paper. And the transmitted ray will go like this without any change. So the definition of this Brewster angle or the polarizing angle, and this is called polarizing angle. Polarizing, or otherwise it is called Brewster angle. Brewster angle. That is, this is the Brewster angle, that is the angle of incidence at which the reflected ray is plane polarized. So this is the plane polarized light. Plane polarized light. Clear? Plane polarized light. This is unpolarized. Is that definition clear? And one more point we have at Brewster angle IP, the reflected ray and the transmitted ray are perpendicular to each other. Clear? Now we should know what this Brewster law means. We know, since this is IP, this is the angle of incidence, the angle between the incident ray and the normal, and this is the angle of reflection, that also will be IP, because the angle of incidence is always equal to angle of reflection by laws of reflection. And we know, let me take this as RP, the angle of refraction, that is the angle between the transmitted ray, that is the refracted ray, this is the refracted ray, and the normal. And we know, when you add these three angles, let me mark this point as some N. This is A, this is some B, let this be C, and this be some N dash. Now we know angle NAB plus angle BAC plus angle, see, this N dash AC, n dash AC is equal to 180 degree, since this n dash is a line, or the angle of a angle on a line is always 180 degree. And we know angle NAB is actually IP plus, see, this one is 90. We know at Brewster angle or at polarizing angle, the reflected ray and the transmitted ray are perpendicular to each other. So this is 90 degree plus angle N dash AC, this one is, we call that as RP, equal to 180 degree. So IP plus RP is equal to 180 degree minus 90 degree. That is actually 90 degree. So you can take RP as 90 degree minus IP. Clear? Call that as equation number 1. Now applying Snell's law at A, applying Snell's law at the point A. When you apply Snell's law at A, we know sine of angle of incidence, that is sine IP, by sine of angle of refraction, sine RP, is equal to refractive index of, see, this light is traveling from air to glass. So we have to take the refractive index of glass first. Refractive index of glass with respect to air. Anything with respect to air, we consider that as absolute refractive index. So let me take that as mu. Mu is the absolute refractive index of glass. Here we took glass, you can take any transparent medium. Okay. Now we have sine IP divided by sine RP is actually sine, instead of RP I can put this value, 90 minus IP is equal to mu. That will give sine IP divided by, see, sine 90 minus theta is cos theta. So cos IP. We know sine 90 minus theta is actually cos theta. So this is equal to mu. Simplifying this, you'll get what's actually sine by cos. The trigonometric ratio sine theta by cos theta is actually tan theta. So tan IP is equal to mu. So this is actually Brewster's law. That is, the tangent of angle of polarizing angle will give the refractive index of the transparent medium. This is called the Brewster's law. Clear?